All right, in this question, they give you some computer output and then ask you some questions. Part A is just use the computer output above to determine the equation of the least squares regression line. Identify all variables you used in the equation. So as far as the equation piece of things, the constant line is always tied to this y-intercept. So my y-intercept will be 0.137. The other line, in this case, is wind velocity. That's always tied to the slope. So in this case, my equation would be y hat equals 0.137 plus 0.240x. Now, they also say identify all the variables. You don't have to do anything tricky, fancy, or anything. They just want to know what is x and what is y in this equation. So x is the wind velocity in miles per hour. Y is the electricity production in amperes. They didn't say you had to include the units, so I don't know that you would get marked off for not having the units, but I think it's better to include the units. The other thing you could have done, they had this as another alternative acceptable response, is you could jam it all into one, and instead of using symbols, just write out that the predicted electricity production equals 0.137 plus 0.240 times wind velocity. And then you're putting the interval or the variables right in there. I probably would do the first one just because that meshes more with how I think about things, but they accepted that second one too. So then in part B, they wanted you to do some work with that equation. They said how much electricity will the windmill be expected to produce on a day when the wind velocity is 25 miles per hour. So we're just taking our equation and plugging in the 25 in for x. And then I had it written as an answer. We would expect the windmill to produce 6.137 amperes of electricity. It probably would be enough to show the work, but I think, again, it's better to clearly answer that question. C says, what would the residual be if the actual amount of electricity produced on the day when the wind was 25 miles per hour was 5.6 amperes? So we just figured out the predicted y, or the y hat, for 25. They tell you the actual amount of electricity for 25 was 5.6. So they're giving you the y. You just need to subtract to actually get the residual. And then part D says, what proportion of the variation in electricity production is explained by its linear relationship with wind velocity? This actually is an easy question if you know what they're asking for. So the key is to identify that this is really darn close to what we have for our statement for what r squared is. So all you really need to do is go, oh, that's just r squared, and then based on the computer output, r squared is 0.873. Again, just ignore that ADJ1. All right, and then this last question here, the second question here, they give you a residual plot, not a regular scatter plot, but a residual plot, and they give you computer output. And A just wants to know, is a line an appropriate model for this data? What information tells you this? Well, the key is look at this residual plot. And since the residuals in the residual plot are scattered with no curve, both of those are important, that's how we know that a linear model is appropriate. B, what is the value of the slope of the least squares regression line? Well, first of all, the constant line is the y-intercept. So here we want the other line, so the 233.517. Then they wanted you to interpret that slope as well. So again, use your notes. But for each increase in the number of years, which is what x is, by 1, the predicted number of commercial aircraft flying in the United States, which is what y is, changes by 233.517 on average. So in C, they want to know what is the value of the y-intercept of the least squares regression line. So now we are going to use that constant line. And then they want you to interpret that as well. So then we would say the predicted number of aircraft flying in the United States, which is what y is, when x equals 0, which is really the year 1990, is 2939.93, which is approximately 2940. Then D says, what is the predicted number of commercial aircraft flying in 1992? Well, if we want a predicted y value, we just need to use our equation, and we're plugging in 2 for x. The catch here again is 1992 is not really our x value. We're looking at the number of years since 1990, so we would plug in 2. And then part E, what is the actual number of commercial aircraft flying in 1992? Well, again, residual is y minus y hat. From the residual plot, we can see that when x is 2, the residual is up here at 40. So I know then that the residual is 40. We just got the y hat value for that year as 3406.96. And so we just need to solve this little equation by adding 3406.96 to both sides. So you end up with a y of 3446.96. Now, they were asking for an actual y value. So in this problem, we really should round to 3447 because that actual number of aircraft would have to be a whole number. When you're doing a slope or when you're doing a predicted y value, it's okay for those to be decimals because they're just based on equations and they're approximates. But when we're talking about an actual y value, we should round it because we have to have a whole number of aircraft.